Assalamualaikum and very good day to everyone. My name is Muhammad Haziq Safi bin Zulkifli. I would like to present my final year project titled Study on Performance of Thermoelectric Generator in Living Room Usage, supervised by Dr. Farah Liana binti Muhammad Rizwan. Do you know that about two-thirds of our energy we use get wasted in form of waste heat, and some estimate nearly 60% of energy are wasted into atmosphere? Scary as it sounds, with a climate change, finding a way to capture this energy is of vital importance. Thus, this is where a device called thermoelectric generator comes in. These devices contain thermoelectric material that has two different compounds which are connected in parallel form and circuit connected in series, and apply a temperature difference across them. Then the electrons want to flow from the hot end to the cooler end, and this thermally induced electric current can be used to power a circuit, converting heat directly into electricity. This phenomenon, where temperature difference can create a voltage, is known as Seebeck effect. Now, as nowadays, we are attracted more interest in smart home devices, room being equipped with sensor and Internet of Things or IoT devices. Commonly, these devices doesn't need any large amount of power. It is crucial along with the global demands for the use of renewable energy sources. Future buildings are headed to a passive house that require significantly less energy for climate control. To ensure we can harvest continuous amount of heat in living space, a passive solar heating come out from our sun, directly contact with house roof or wall that produce thermal radiation. Thus, a method that can produce electrical energy effortlessly with a cheaper cost by harvesting unused or waste heat present in a room. It could also be a good solution to power these devices. Our research objectives is focusing on studying the most feasible and suitable TEG design in the home application, with detailed objectives as follows: to perform an analytical modeling of TEG modules using MATLAB simulation for application in living room area, and design a suitable TEG system to be placed in living room area based on simulation performed. This includes the quantity of TEG needed to be placed in the selected living room area. The main focus in this research is to harvest waste heat present in the living room by using TEG module as alternative uh, renewable energy to produce electric used by IoT devices such as sensor and controller. There are plenty of thermoelectric modules available in the market which come up with various output power and sizes depending on its usability. By selecting this commercial module, we can collect the output value from the manufacturer parameter data, and by developing the data using numerical simulation method in MATLAB Simulink software, we can obtain and compare the device performance. Thus, from the result, we can select the suitable module and design the TEG system operate for specific application which have different temperature gradient, for instance, living room space. The first literature review I take from this study was titled Smart Thermoelectric Waste Heat Generator: Design, Simulation, and Cost Analysis by Guinea Omar et al. In 2020. This study produced Smart Thermoelectric Waste Heat Generator called STWHG. The author performed laboratory and field tests for the generator and examined power and cost parameter of STWHG installed in the power plant industry. The strategy in this research is simulate using MATLAB for real working condition of STWHG and compare the result with a direct measure parameter of a power plant with a capacity of 150 watts at temperature difference of 100 degrees Celsius. The research gap in its application use of TEG, which was conducted in larger industry power plant area to harvest much bigger amount of heat source. For the second literature review, from the title Annual Energy Harvesting Performance of First Singe Material Integrated Thermoelectric Power Generation Block in Building Wall by Yu Suk Byun et al. In 2020. This study is to produce harvesting block, perform laboratory tests, and predict the electrical annual generated by harvesting block. The strategy is simulate using TRN-SYS-18 and evaluate the passive electricity generator called harvesting block. This system contains TEG, phase changing material or PCM, is designed to harvest waste heat in the exterior wall. The research gap was the author using PCM material attached at the cold side of TEG to increase the potential output power and conducted in Korea, which have 4 different seasons. And for the third title, Thermoelectric Generator Characterization at Extra Low Temperature Difference for Building Application in Extreme Hot Climate. Experimental and numerical study by Muhammad Al-Musli et al. In 2020. This study developed the experimental setup and the numerical model of characterization test in the low temperature region for building envelope integrated TEG application in United Arab Emirates. The strategy is simulation using COMSOL Multiphysio computer modeling software as platform to develop and test the model. The model allows the detailed characterization of the TEG in open circuit and loaded condition. The research gap which the author conducted based on the extreme hot climate located at Middle East. This flowchart indicates the purpose, methodology, and the result discussion in order to achieve the objective in this study. The flowchart consists of steps needed to be taken in order to retrieve the data to obtain the aim of this study. The first step in this methodology is the selection of the thermoelectric module. This study had selected TEG12411 6.0 manufactured by TEC TEG Manufacturer Company as the module to operate throughout this experiment. The characteristic of selecting the TEG module was based on the dimension, the maximum range of temperature difference values obtained from manufacturer datasheet, and to test its reliability with simulation modeling. The specification obtained by manufacturer shows that the TEG contains 126 of thermocouples and the material used is a hybrid of lead telluride and bismuth telluride with a dimension of 56 mm x 56 mm of size. As we can see in the table, the maximum temperature of the module can receive are 300 degrees Celsius at hot site and 30 degrees Celsius at cold site. The maximum match voltage, current, and the power produced are 8.8 volt, 2 amps, and 17.6 watt respectively, and the open circuit voltage at 17.7 volt. MATLAB Simulating Modeling. The TEG modules presented here are the MATLAB simulating libraries compatible, allowing for further DC and AC electronic circuit simulation. Simulating block libraries are used to create this model. The block model is more user-friendly because of the mask icon. The purpose model implemented of this mask icon to make it easier to use and understand by inserting image file of TEG icon. Then the develop of subsystem block in the modeling by using simulating libraries, with the important parameter of the TEG modules can be configured. After we insert the value of temperature difference based on the datasheet by manufacturer, the parameter of the TEG module can be obtained. The model parameter consists of seepback coefficient, resistance, thermal conductivity, and figure of merit. On the right side of the figure shows that the derivation equation for each parameter using command on the MATLAB libraries. The output of the TEG depends on the parameter properties that listed on previous slide. Thus, from the parameter properties, the output power on simulation data using MATLAB simulation, MATLAB simulating modeling method for TEG module can be compared with the datasheet provided by manufacturer, which on the right side. The similarity value achieved from the primary result prove that the method equation can be used to target application. This study had collected climate data from previous study titled Effectiveness of Free-Running Passive Cooling Strategy for Indoor Thermal Environment, example from two-story corner terrace house in Malaysia by Ning Wai Tak et al. In 2019. The measurements were conducted in two-story corner terrace house located in Taman Melati, Kuala Lumpur through 14 days from 15 February until 11 March 2018. The two different conditions was taken applied in the experiment which at external wall surface and ceiling bottom surface shown in the table. The cold side was fixed at 26 degrees Celsius as the average room temperature in tropical climate. From the result, from the left side of the result shows the graph of 7 hot side temperature respect to the output voltage. The graph shows gradually increase when the temperature start at 36 degree until 40 degrees. The respect to the current output, the current gradually increase when the temperature at 37 degrees and constant between 39 degrees. The power generation selected at the highest temperature at 40 degrees shows that TE module can generate power of 30 milliwatts and the output voltage and the current at 0.37 volts and 0.08 amps respectively. At the external wall surface shows that the pattern of output power generated throughout 14 days within the mean value of 0.02 watts and the standard deviation of 0.3%, with the highest power output produced was 0.025 watts. And for the ceiling bottom surface, we obtained the mean value of 0.025 watts and the standard deviation of 0.4%. With the highest output produced was 0.03 watts. From the both results, we can agree that the experiment can be used due to the standard deviation value was below 1%. For the comparison between both conditions, we can see that the mean value at ceiling bottom surface was slightly higher than external wall surface. Thus, to select ceiling as the place for TEG system. In this picture show where the desirable place of TEG system should be mounted and the quantity of module needed was about 60 modules. For the conclusion, modeling in MATLAB Simulink is one method in determining which modules are appropriate for specific purpose. The desirable option to install TEG block is at ceiling bottom surface as ceiling receive more heat than wall for tropical climate in Malaysia. According to Bune, in 2020, when installing the TEG block, the most important element to consider is whether the location is well heated during the days and well cooled by the atmosphere at night. It could be concluded that the prediction quantity of TEG block in the system at 60 modules with the average generated power output value of 0.03 watts and the voltage of 0.35 volt. According to Al-Muslih in 2020, for activation of modern digital and radio frequency circuit require voltage of 1 to 2 volt, but higher performance analog circuit require voltage of 2 to 3 volt. And lastly, to evaluate the application feasibility of the proposed energy harvesting method, further additional experiment in real buildings should be carried out. And this is the reference from this study. And last but not least, I would like to sincerely express my gratitude to my supervisor, Dr. Farah Liana binti Muhammad Rizwan, for patient guidance and advice provided, and for the members of ICOSA in Wind Engineering for Urban Artificial Man-Made Environment for me to improve throughout the RINCO session guidance. That's all for me. Thank you.